Okay, this is the P3 paper from October 2021. This is question number 4. And as we can see by looking at it, this is a trig addition formulae question. We're going to be using the addition formulae to rearrange question number 1 from what we have to start off with into tan theta equals 2 root 3. And then after that, we're going to be solving a trig equation. Okay, let's look at part A then. Part A says we have 2 sine theta minus 30, which is equal to 5 cos theta. And we, as I say, we want to try and get that to look like tan theta equals something. This is what we should notice. We've got sine A minus B here, and sine A minus B is sine A cos B minus cos A sine B. So that's definitely my first step. I'm going to multiply out the bracket. 2 sine theta cos 30 minus 2 cos theta sine 30 equals 5 cos theta. Let's work out the cos 30 and the sine 30. You should know what they are anyway, but cos 30 is root 3 over 2. Sine 30 is a half, equals 5 cos theta. That tidies down to root 3 sine 30, root 3 sine theta minus cos theta is equal to 5 cos theta. And then if you didn't already know what we're aiming for at this stage, if I can get cos theta and sine theta on the separate sides, which I'll do now, so root 3 sine theta is just equal to 6 cos theta. If I now divide both sides by cos theta, or if you take that down there, in effect we're doing that, I'm going to get sine over cos, and sine over cos is tan. So in fact, let's take that down there. At the same time, let's take that down there. Let's save ourselves a bit of time. I'm going to get sine theta over cos theta is equal to 6 over root 3, which gives me tan theta equals 6 over root 3. And then remember, with surds, we can't leave a surd in the denominator. So times top and bottom by root 3. I'm going to get tan theta equals 6 root 3 over 3. And then, as if by magic, 6 divided by 3 means that we end up with tan theta equals 2 root 3, and that's what we were aiming for in the first place. So absolutely fantastic. That's that first bit done. Second bit says hence or otherwise, which means hence. It means use part A to do it. So what have I got here? I've got 2 sine and 5 cos, and I've got 2 sine and 5 cos. So if I'm looking at them and comparing them, this really is the indicator. Look, theta should be x plus 20. Does that work out there as well? Yes, it does. If theta is x plus 20, I'll get x plus 20 minus 30, which is x minus 10. Go through that a bit slower in a second. So I know what I'm doing for part B. So let's say that if we say theta is equal to x plus 20, then where I've got 2 sine x minus 10 equals 5 cos x plus 20, that then actually is the same as 2 sine theta minus 30 equaling 5 cos theta here. That's theta, and theta minus 30 works out to be that if we have theta equals x plus 20. So now I can straight away say then, using that, okay, well, tan theta then, is equal to 2 root 3, because we're just going to use this same idea that we can just drop that straight down to be equal to that. So if that's the case, theta works out to be equal to, just do inverse tan, we get 73.9. It's in, using the cast diagram, all sine tan cos, it's in the first and third quadrant, so we also get 253.9. Go back and look at my channel for how to solve trig equations if that causes you any problems. So that's theta, but we don't want theta, we're trying to find x. So x plus 20 is equal to those two bits, which means that the possibility for x is 53.9 or 233.9. Just go back and check for decimal places and significant figures. They wanted it to one decimal place. I've done that. I've made sure I've solved my equation in the right range there. Always do that double check for any of the trig equations, but hopefully that makes sense for question number 4.